Hi, so I just wanted to catch everybody up as to where we were when we stopped off a couple weeks ago before we had to leave campus, and where we are in terms of our lecture. We had just started chapter 36, Resource Acquisition and Transport in Plants, and we had covered this material right here, Resource Acquisition, including shoot architecture and light capture. So one of the things we talked about was the trade-offs between the height and the branching pattern of the shoots, and what the benefits are of growing tall versus branching off. We talked about how larger leaves require more water. They are better at doing photosynthesis, but one of the trade-offs of being larger means they require more water, and so they can only exist with large leaves in certain environments. We also discussed phyllotaxy, which was the arrangement of leaves on a stem, and that it occurs in a pattern which typically reduces overlap between the leaves, and that makes photosynthesis a lot more efficient. We talked about the leaf area index, which is a way of measuring the overlap between the leaves if it occurs on a plant. And plants with a higher leaf area index, greater than 0.7, typically start to self-prune, which means dropping some of the leaves that are being shaded out, which makes the overall plant a lot more efficient. This is an example of the leaf area index, and you can see in this one right here on the left, there's not very many leaves being shaded out. This plant is doing pretty well. This one, there are a lot of leaves being shaded, and so that plant will self-prune and drop some of its leaves. We also talked a little bit about roots. We discussed how roots can grow in particular directions in a way that enables them to have better access to water and nutrients. And we also talked about mycorrhizae, which is basically a fungus that forms a mutualistic relationship with the roots of a plant and helps the roots of the plant absorb water and minerals, in particular phosphates. We then talked very briefly about the importance of internal transport in all organisms with large bodies. And we talked about that some plants don't require internal transport or don't have internal transport, and those are the plants over here in the non-vascular area. So these plants do not have internal transport mechanisms, while these over here do. These are our vascular plants. Finally, we started talking about osmosis and water potential, although we didn't get very far with that. And so the next lecture that you guys are going to get, the next video you guys are going to see, is going to be talking about osmosis and water potential. And then later on, we'll talk about how that's important in terms of water movement in plants.